let's take a look at 4.3. We just drew a whole bunch of stuff on your unit circle. And we're going to put some more stuff on there. It's okay. We're going to do this. 4.3 is talking about coordinates now of each of these points. And there's some coordinates assigned to you where the angle intersects the circle. There's some important patterns we're going to start noticing. All right. So as you're looking at the coordinates of points assigned to you where the angles intersect the circles, here's what we want to look at. What relationships or patterns do you notice in our coordinates? Let's draw a little mini one here, and then we're going to put some info on our front page with our unit circle. So draw a unit circle here. There are some points that definitely fall along our coordinates that we would need to be having. And some of those key ones are the tall, skinny rectangle that we had. So I'd like you to kind of draw that idea here, that we had a tall, skinny rectangle. And this happened at our pi over 3, our 2 pi over 3, our 4 pi over 3, and our 5 pi over 3. Okay. We're going to add some detail here as examples, and then we'll also go back to our big old unit circle, and we're going to put some more stuff on there. Okay. This point, when we think about the coordinates of what these would be, this point, looking at our x coordinates going on here, well, there are some key points that we do know, and we've already mentioned that this is 1, 0, and negative 1, 0. This point here is actually exactly halfway between these two. If you don't believe me, you can go look at your unit circle and prove it. I'm looking at this point right up here. And if here to here is 1 unit, each of these tick marks is, let's see, 1/10, 2/10, 3, 4, 5, 6, 7, 8, 9, 10. Yep, they're in tenths. So at 1, 2, 3, 4, 5 tenths, that's half right there. And so that's our coordinate for half. Okay, so that is an x coordinate of 1/2. Now check this out too, while we're here and looking at it. This guy is 1/2, and that means that I can follow that same 1/2 down. And this guy down here, 5 pi over 3, also has an x coordinate of 1/2. And because they're in this this rectangle relationship, these guys are also at 1/2. It's just a negative x value. They're at negative 1/2 and negative 1/2. Okay, so we can start putting those in for our x values. Each of these was 1/2, 1/2, and this was a negative 1/2, negative 1/2. That's kind of cool. Start to see some patterns where we can start to fill in some answers. Not only that, but we also can look at our horizontal rectangle. See this guy here? This one doesn't fall so nicely on grid lines, but the y coordinate does. And that y coordinate, spoiler alert, is at 1/2. Because instead of this being a tall rectangle, it is now just turned wide. And so it's 1, 2, 3, 4, 5 tenths of the way to positive 1. It's halfway there. So we're going to start seeing some more patterns emerge, that the same thing is even happening with our horizontal rectangles. Pi over 6, the 1/2 was the y coordinate. And that means our same positive y coordinate now is happening over here in quadrant 2. And they just turn negative for y coordinates in quadrants 3 and 4. So, we can find some of these patterns that if they are in the same quadrant, but half of each other, like pi over 6 and pi over 3, that their x and y coordinates are going to switch. Now, we don't know yet whatever is going to be in here or here, but I'll tell you what, those coordinates are going to switch with each other as well. Now, I bring this up because I know I looked ahead. Some of our questions in here are going to ask you, well, hey, if we know the coordinates of point C and that we're going to use the same thing for point D, and you're like, man, it's right across the unit circle, it's going to be the same coordinates because it has just it's moving the same y value up. It's just that the x coordinate's going to turn negative, right? So I've already got my answers written here. Spoiler alert, answers coming. When it moves over like that, it's got the same y value. It's just that the x has switched to negative. So we already know if we're given some coordinates in one place, we can find them in another. So we're looking for these kinds of relationships, that if they're in the same place and we can go through there, we can find some values. So, back to our master unit circle. I'm just going to use a pen and I'm going to add some known coordinates. Alright, so we know our cardinal points at 1, 0, and over here at negative 1, 0. We know straight up at 90 degrees, it is 0 because our x's are not moving, and a positive 1. And straight down at 3 pi over 2, or 270 degrees, we're looking at a 0, negative 1. We have just said that we don't know necessarily our y coordinate, but at pi over 3, it's something, it's 1/2 something. Let me get my white out, because we don't know what that something is yet. All my students just groaned, me and my yets. So if it moved this way for 1/2, that means 5 pi over 3 is also 1/2 something. And 4 pi over 3 is just a negative 1/2 something. 2 pi over 3 is also a negative 1/2 something. Pi over 6, we said we don't know our x coordinate, but we do know our y coordinate was at 1/2. So something, I'm just going to leave it blank for now, 1/2. 5 pi over 6 also has a positive y value. Tells me that here in quadrant 2. 1/2. So now the 7 pi over 6, don't know what our x coordinate is yet, but our y coordinate is negative 1/2. And same thing with our 11 pi over 6. Just keep on kind of tracing these things so that I can see how these things are connected going on here. Now we're going to start thinking about some other ideas. We can find some other points on here that are exactly on grid lines, but none of our others that we've marked here are exactly on grid lines. I see some ones here, like this guy right here. See him? He's right there on a grid line, but he's not one of our marked angles. So we could just calculate him. He's 1, 2, 3, 4, 5, 6, 7, 8. 8/10. So he's a 0.8. And 1, 2, 3, 4, 5, 6. Right? 0.8 and 0.6. We could have that. But he's not one of our marked angles, so I'm just going to stick with right now these 1/2s going around looking for those patterns. And we can actually calculate what that other coordinate would be. So I just want to get you thinking now. I'm going to use some post-it notes to help me isolate that idea. What we have is a triangle right here where the hypotenuse is 1. We set our x-coordinate, our length is 1/2. We can calculate what we need here. 1/2 squared plus, I don't know yet, squared has to equal 1 squared. A squared plus b squared equals c squared. 1/2 squared is 1/4. It's half of a half. 1 squared is still 1. Well, 1/4 plus something to equal 1 has to be 3/4. Taking the square root of each of these, I can't simplify the square root of 3, but I can simplify the square root of 4. It's just 2. Now that's like 0.866 on my calculator. You might be like, well, how did you know it's 0.866? It's because math. And because I've been through math before. And because I had to memorize all this stuff at one point in my life. Look, there it is, 0.866. So I did that square root of 3 divided by 2 and got 0.866. But root 3 over 2 would be the other part of it, approximately 0.866. Now, that's a little advanced, but, just want you to know that as long as we know one coordinate, we can solve the other one using what we've already talked about in this chapter. All right, there is lesson 4. Keep this page tabbed. We're going to come back to it a lot.